Back everyone to another episode of the Doom series, and in this video we are going to use the dynamic arrays that we implemented in the last video, and we are going to use that to optimize our floor rendering and use a vertex array for that. So in order to move on with this optimization, the first thing we'll need to do is inside of mesh.h I've just made a couple of type defs for easy access of vertex and index arrays. So we have type def dynamic arrays of type vertex and uint32 as vertex array and index array respectively here. Of course we need to include the header, and that's pretty much it, and all of the other code is in engine.c. Now in here make sure to include dynamic array.h, and if I go down here you can see that all of this is pretty much the same as before. Nothing really has changed, and the stuff that has changed is inside of this generate meshes. So now in here we generate a single mesh for all of the flats, and we do not generate like multiple meshes for the flats, but instead we generate a single mesh. So for this we are going to first of all create a draw node pointer just like we were doing earlier, and then we don't have any of the nodes inside of our loop, but instead we create a single node called flats node, and we allocate the size appropriately. And after that we just set the next value to null, and we set the texture to -1 because, well, we are using the other array texture for this. And then we to create a vertex array called vertices and an index array called indices, and then we initialize those arrays with a capacity of 0 by default. Now in here we start our loop, and here we first of all create a single variable called start index. Now this will represent the index that's starting for this particular polygon, so that we can use it when we are doing triangulation. So if I go here, all of this is pretty much the same. We don't allocate memory we do allocate memory for vertices here because well, this is much easier for processing and stuff. Later on we'll free the memory and copy the data over into our vertex array, inside of this, as you can see, we just go ahead, and after we have done all of the processing on the vertices and we have got the correct data, we go over the vertices and we push the floor vertices and the ceiling vertices, both of them. So we just do that, and here we create another variable for the ceiling start index, and this will represent where the ceiling polygon starts, so the index for that, which is just set to vertices.count, which is the current index. So we just use dynamic array push to push all of the floor vertices and the ceiling vertices into our vertices array. Now we do not allocate any memory for the indices, but instead we just loop over that. So we've got j is equal to 0, j goes until number of vertices -2, because with fan triangulation, that is the number of vertices, that number of triangles that will be formed, and we just do j++ and this k++ as well. So in here what we do is we push this value, but instead of pushing 0, k and k+1, we push start index, and here we also add the start index to these values. Now for the ceiling ones we just add the ceiling start index instead, and what that does basically is that it gives us the correct offset so that we can calculate the triangulation correctly and put everything inside of one big mesh. And in the end we set the start index to the vertices count, so that when we are going in the next iteration of the loop it works, and we free the floor and ceiling vertices, but of course we have not allocated any custom memory for the indices. Now we do the mesh creation outside of the loop, of course, because we are creating only one mesh. So we create the flats node mesh with the vertices count data and the indices count and the indices data, and then we set the drop node pointer to flats node and set its value to flats node and set the actual pointer to the next value, just like we were doing earlier. And then we use dynamic array free to free the vertices and the indices arrays that we have created. And here we have got the quad indices, and all of the other stuff here just follows similarly. Now in here if I run this, you can see that the only thing that actually appears to change is, well, there's actually nothing changes, but the main difference is that now we are issuing only one draw call to the GPU for all of these flats. So all of the floors and all of the ceilings are being rendered with a single draw call and not multiple ones like we were doing earlier. So this is all pretty awesome, but we also would like to do the same for walls, because currently we are using a lot of draw calls for walls. But for that we'll need to first of all figure out how to deal with texturing in the walls, because currently with the way we've got, we are using a separate texture for each wall, and we can't set uniform if we have got like a single stuff inside of our uniform object. So if you have got textures as uniforms, then we need to call the meshes separately, but we'll need to figure out a way to kind of merge those into some other way by using a texture atlas or a texture array. We'll look into that in the future video, and then we will make it so that we can use that to basically render all of the meshes, wall meshes at once as well. And that will be quite a big boost for performance, because it takes like a lot of effort for the GPU to send one mesh to the GPU. So we should try to minimize the number of draw calls in our GPU. Anyways guys, I'll see you in the next video. Make sure to like and subscribe as well, and share this video with other people. And